Hi, it's Liz Nedden. Let's have a look at the 2020 NZQA exam for Level 3 Probability Distributions. And here's the answer to question 1A, Part 1. So what we've got is we have some information here about times to do meals. And in particular, you've been given information about for lunches that it takes anywhere between 5 and 25 minutes. Then for dinners, it takes anywhere between 5 and 30 minutes. So what I do is I look at that information and go, I've only got two values for each of these distributions, lunch and dinner. And so which distribution would this be? And this must be our uniform distribution because 5 and 25 are our minimum and maximum. So what I have is I have my lunch is a uniform distribution, and that has an A value. The minimum is 5 and the maximum is 25. Then we have our distribution for dinner, and dinner is also a uniform distribution, and that has a minimum of 5 and a maximum of 30. So that's what I know first, as I've got these two distributions. Then I've been asked in part 1, it says sketch the two distribution models on the grid and identify which is lunch and dinner. So what I've done is I've just made myself a couple of boxes here, which are going to be my uniform distributions that I'm going to put on my grid. So before I can put things on the grid, I need to set it up. So it means I need to know what my scale is. So on my y-axis, this is going to be my f of x value, or the height. And on my x value axis, this is going to be, in this case, the time, and that's going to be in minutes. So I look at the numbers and go, well, the maximum number of minutes I've got is 30, so that means I want my scale on my x-axis to go up to 30. So I'm just going to start at 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, there's 15, 16, 17, 18, 19, 20, 2, 3, 4, 25, 1, 2, 3, 4, 30, and so on. Okay, so that's my x-axis scale set up. Now I need to work out the height. And so in order to work out the height, I've actually got to do a calculation first. And so on your formula sheet, you have been given a formula, and I'm just going to grab that from over there and paste that in here. So this is the formula that you are given on the formula sheet. And so that shows us that your height is this formula here, 1 over b minus a. So that is f of x, which is your height. So that's what we want to use. And so I need to do this height both for the lunch and for dinner. So for lunch, my height, or my f of x value, is 1 over, and the b value for lunch, if I go back up here, my lunch value b is 25 and a is 5. So I'm going to go 25, take away 5. So that gives me 1 over 20. Or if you want that as a decimal, then that would be 0.05. Then I need to do dinner, and its height is 1 over. And so if we look at the dinner values, dinner height, b is 30, a is 5, so I'm going to do 1 over 30 take away 5, so 1 over 25, which is the same, if you want that as a decimal, of 0.04. Now the reason I just wanted these ones as decimals is it's easier to do a scale when they're a decimal value. So that is what I need the values to go up to. So on my axis here, I'm going to go up 0.01, 0.02, 0.03, 0.04 and 0.05. So that gives me my scales. So now I can do my distributions. So lunch, I'm going to grab that, goes from 5 and goes all the way across to, lunch goes over to 25, and lunch, if I jump down there, lunch has a height of 0.05. So I'm going to do this up to there. So there's my rectangular or uniform distribution for lunch. Now, I don't want to move that. Dinner is going to also start at 5 minutes, and it is going to go up to 30 minutes. And the height of dinner we found was 0.04. So I want that just to go up to there. So there are my two distributions. The blue one, the one behind, is lunch, and this one in front, dinner, is that. So that's the answers.